Hello, Assalamualaikum. My name is Muhammad Firdaus bin Muhammad Fauzi. My matrix number is CE200192. Today I want to present Lab 3 Power System. So I will start with the introduction. Wires and circuit traces start to impair circuit performance when the physical dimension of circuit approach to the magnitude of a signal wavelength. Because the effects are frequency dependent and often have extremely small values that are linearly dependent on wire length. This is the case. The impedance becomes non-negligible when the frequency and length are comparable. The wavelength wire length ratio as low as 0.01 can be considered. Compare the rising time of the signal to the propagation delay as a mental shortcut to avoid having to evaluate the harmonic components of a signal. Transmission the line effect must be addressed if the rising time is less than twice the propagation delay. Any signal with the rise time of less than 10 nanosecond will be influenced by transmission line effects if the propagation delay of a wire or trace is 5 nanosecond. So that's all for me for the introduction. Thank you.
Assalamualaikum and good day, Doctor. My name is Nabila binti Rahim, matrix number DE200124. And today I will present for exercise 1, short transmission line for lab 2. So, this lab is require us to search for voltage regulation and efficiency. So, in the exercise 1, we need to find the voltage regulation and efficiency when it is 0.8 power factor lagging and 0.8 power factor leading. So this is the MATLAB coding for this exercise. After I run this coding, and then the MATLAB will generate these numbers. So for the first one, 0.8 power factor lagging, I get the value for VSLL, that is 250.01x6. So VSLL is sending end line to line voltage. So in the manual solution, we also get 250 kilovolt. And then for the SS, that is sending end power, we also get the same value as manual solution, that is 322.8 megawatt plus J 288.6 mega VR. And then the regulation is 13.64%, that is was the same as manual solution. And then the efficiency is 94.42%, that is was the same as manual solution. And next is for 0.8 power factor leading, the VSLL, that is sending end line to line voltage, we get 210. It was the same as manual solution, that is 210.26 kilovolt. And then for the SS and that is sending end power value, we also get the same, that is 322.8 megawatt minus J 168.6 mega VR. And then the voltage regulation was the same, that is negative 4.41%. And then for the efficiency is 94.4%. I think that's all for exercise 1. Thank you.
Hello and Assalamualaikum. My name is Muhammad Syamil bin Abdul Hadi and I'm going to do the program for medium transmission line. So for this coding, I just copy from here. So I change a little bit because if I use this, it will be an error. So if you run this coding, we need to enter the length of line, receiving voltage, power factor, into L, R and C value. The value we can get from the equation. Okay, for the into the length of the line, the value is 200. Receiving voltage is 132,000, and for power we got 50 mega, and for power factor we got 0.8. And then for the value of L, we got 1.29 milli, and then for C we got 0.009 micro, and for the R we got 81. Okay, after that we can find the value for this one. Okay, in MATLAB, the answer given in the rectangular form, and for the manual calculation, the answer were given in the polar form, so it will be a little bit different. So for the Z, this one is Z, and then Y is this one, and A this one, B and C. Okay, for the IR, we got 2.1861 E plus 02 minus 1.6414 exponent plus 002 I. In the manual, we got 0.2734 negative 36.9 degree kilo. Okay, for the VR, we got here VRPH, and this is for manual one. And for the VS, this is the answer from the MATLAB. This is from the manual calculation. For the IS, this is the answer from the MATLAB, and this is from the manual calculation. Okay, for the efficiency, this is the answer from the MATLAB, 82.95, and from the manual calculation we got 88.5%. Okay, for this one we only can calculate it in the manual calculation. Okay, that's all for me for the medium transmission line. Thank you.
Assalamualaikum. My name is Nur Adila Adha bint Abu Bakar, DE2 00064. I will explain a bit about the simulation tree. So this is the program for the Y bus. We will generate the matrix for the Y bus at the end of the coding. So this is a part where we declare the number of buses and the number of impedance that we use. As you can see here, this is the input that I already insert, which is this for the line number 1, this one is for line number 2, and this one is for line number 3. And then we can see here the formula to get the final value for the Y bus matrix. We can see here we are using the function for in this coding, and at the end of the code we can get the final matrix here for the Y bus matrix programming. So I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh to Doctor. My name is Muhammad Fidel Ramli. Today I would like to present about discussion. For this lab is to determine the assessment of voltage drop, line losses and transmission efficiency all significant issue in the design and operation of the transmission line. These values are heavily impacted by a transmission line constant R, L, and C. For example, the voltage drop in the line is determined by the value of the three line constant shown. Similarly, transmission line conductor resistance is the most significant cause of the power loss in the line and the influential transmission efficiency. Furthermore, the capacitance existing between the conductor is a one-phase line, or between a conductor and neutral in a three-phase line generates a short road along the length of the line. For example, the short transmission line, medium transmission line, and the long transmission line. Voltage regulation is the difference in the voltage at the received end of the transmission line between no load and full load situation, represented as a percentage of the received end voltage. Okay, next, conclusion. In the conclusion for this lab, to represent different type of transmission line. Type of transmission line include parallel line, for example, ladder line, twisted pair, coaxial cable, and the planar transmission line such as strip line and microstrip. The higher the frequency of electromagnetic moving through a given cable or medium, the shorter wavelength of the wave. Besides that, to understand the typical behavior of short and medium transmission line. Lastly, to determine the voltage regulation efficiency of the short and medium transmission line. Thank you.